Hello students, today we are going to learn about preparation of alkanes. What are the different methods of preparation of alkanes? The process is known as Kolb's electrolysis. In Kolb's electrolysis, the sodium or potassium salt of carboxylic acid is taken. Suppose we take CH3COONA. The aqueous solution of sodium ethanoate is subjected to electrolysis and we get ethane, hydrogen, carbon dioxide and sodium hydroxide as the product. So it's difficult to remember the products here. So what is the method of getting that? The mechanism we will see in detail. So the reaction is two sodium acetate molecules. When it reacts with two molecules of water, it results in ethane, hydrogen, carbon dioxide and sodium hydroxide. We'll see how the products are obtained. So what are the reactants here? We have CH3COONA and water as the reactants. So in the presence of electricity, we find that it will ionize and produce CH3COO negative and Na positive. In addition to that, water will ionize and produce H positive and OH negative. Now what happens at the anode, that we will just see. So here you find that anode means it is the positive electrode and the anions that are present will reach near the anode. So you find that acetate ions reach there, that is CH3COO negative ion reach there. This anion loses one electron to the anode and it results in the corresponding free radical. So the acetate free radical is formed. CH3, C, double bond O, single bond O with an odd electron here. So when one electron is lost, you get the number of electrons here as 1, 2, 3, 4, 5, 6. So odd electron is present and so this is acetate free radical. That is, acetate ion loses one electron and produce acetate free radical. Know that free radicals are odd electron species and so they are having a capability of attracting other free radicals or somehow they have to get it paired. So you find that free radicals are highly reactive. So they will try to just stabilize themselves somehow. So this acetate free radicals undergo a rearrangement here. One electron gets shifted to the single bond here. Subsequently, the CC bond breaks. One electron from here also enters, resulting in a double bond here. One electron that is there will go on the carbon, resulting in CH3 free radical plus a neutral molecule, that is C double bond O. Here it becomes double bond, so this is carbon dioxide that is produced. So From one acetate ion, it loses one electron, forming acetate free radical, which will rearrange and form methyl free radical and carbon dioxide. So we find that we have taken two molecules of sodium acetate. So you find that two sodium acetate ions are used up, and so it removes two electrons to form two acetate free radical, which will result in two methyl free radicals and two carbon dioxide molecules. Now in the system we have got two methyl free radicals. We have told that free radicals are highly unstable, so the two free methyl free radicals will come close by and they will join together to form methane molecule. So at the anode we get ethane and two molecules of carbon dioxide. At the same time, what happens at the cathode? So cathode is the negative terminal, and here at the negative side you find the cations reach there. So what do you have remaining there? We have water molecules in the form of H plus and OH negative ions. So at the anode we have seen that acetate ion removes electrons, so it is oxidation that happens, it is loss of electrons. Whatever is lost at the anode must be gained at the cathode. Since two electrons are lost there, those two electrons are to be gained at the other side, and here you find that the H plus ion take up two electrons. So for taking up two electrons we require two molecules of water, and you find that it results in two hydrogen atoms and OH negative two ions are produced. So you find that the two hydrogen free radicals or the hydrogen atoms will combine together to form H2 molecule. At the same time, near the cathode you find that Na plus ions that was present in the previous section, you find it will react with 2 OH minus, resulting in 2 NaOH. So we are able to explain the formation of the four different products in the electrolysis. At the anode we got ethane and carbon dioxide, and at the cathode we are getting hydrogen and sodium hydroxide. So that results in the chemical reaction that is called electrolysis. That is, in the process of electrolysis of sodium ethanoate, we got ethane, hydrogen, carbon dioxide and sodium hydroxide as the products. Ethane and hydrogen are obtained at the anode. Ethane and carbon dioxide are obtained at the anode, whereas hydrogen and sodium hydroxide are obtained at the cathode. The next method of preparation of alkanes is starting from Grignard reagents. Alkyl magnesium halide is known as Grignard reagent, and it is prepared by the reaction between alkyl halide and magnesium metal in the presence of dry ether. It results in alkyl magnesium halide. Remember that it will ionize to form Mg plus X minus, and this will be ionized as negative. So when alkyl magnesium halide is subjected to hydrolysis, that means reaction with water. You find water can be written as H plus and OH minus, and that will result in the compounds. Here opposite sides will combine together, resulting in R H, and it will result in the corresponding alkane, and MgXOH is formed as the side product. So suppose if you are taking ethyl magnesium bromide reacting with water, you find it will ionize to form C2H5 negative and Mg positive. So then the product formed will be of the type C2H5 combines with H plus and MgBr combines with OH negative, and that results in the compound C2H5H plus MgBrOH. So C2H5H is nothing but ethane. So starting from ethyl magnesium bromide, we are able to prepare ethane by hydrolysis of Grignard reagent. Alkanes can also be prepared by the reduction of alcohols, aldehydes, or ketones. So if you take the alcohol, so suppose we are taking methanol as the reactant. Methanol, when it reacts with hydriodic acid in the presence of red phosphorus at a higher temperature, you find that it results in the formation of methane. So that is, two molecules of HI will combine and result in CH4. Find it will also react with hydrogen and OH, forming H2O along with iodine. So these are the different products of reduction of alcohol, that is methanol. So methanol on reduction results in methane. Suppose that we have taken ethanol, CH3CHO. So this contains two carbon atoms, and so the compound has the name ethanol because it is an aldehyde. The name should end with al. So ethanol, when it is reacting with hydriodic acid and red phosphorus, it undergoes reduction. So here you find that we have to remove oxygen. So oxygen is removed from the compound and it is removed as water, for which we require two atoms of hydrogen to be combining with oxygen. So when it removes, you find that it results in an unstable compound. So if you take two molecules, that is not enough. So here you find that two bonds are free here, and so it is actually CH3 CH double bond O when it reacts with HI, how many molecules of HI are required? That we'll see. Here you find that oxygen is abstracted by hydrogen and it will be removed as water, for which you require 2 atoms of hydrogen. It's not enough that we have to fill in the bonds here. So 2 hydrogens here plus 2 hydrogens are required. Total 4 hydrogens are required, and so we use 4 molecules of HI. So when 4 molecules of HI react together, it results in CH3 single bond CH3 plus H2 plus 2 molecules of iodine. Hope it is clear. That is, ethanol, when subjected to reduction, it gives ethane, water and iodine. Now take ketone. So the simplest ketone taken is CH3C double bond O single bond CH3. When it is subjected to reduction in the presence of HI and red phosphorus at a high temperature, what happens here? Again, the oxygen must be abstracted, so it has to be removed as water. So you have to remove water from the compound. Another product that is formed will be iodine. Now we will check how many molecules of HI are required. So here, to remove water, we require 2 hydrogens. So 2 hydrogens and oxygen together will be removed as water. Then we have 2 bonds free here. So 2 hydrogens are to be substituted there. So 2 hydrogens are to be added there. That results in CH3, CH2, CH3. So what are the products formed? Propanone, on reaction with HI and red phosphorus, will give you propane plus water plus iodine. So here you have to take 4 molecules of HI in the presence of red phosphorus, resulting in propane, water and 2 molecules of iodine. Ketones and aldehydes can also undergo reaction with zinc amalgam in the presence of concentrated HCl to give the corresponding alkane. So suppose we have taken CH3CH double bond O, or if you have taken CH3C double bond O CH3, if it is subjected to the reaction between zinc amalgam, that is zinc in the presence of mercury, and concentrated HCl, if you are heating the compound, the reaction is known as Clemenson's reduction. So in both the cases, we are using zinc amalgam in the presence of concentrated HCl. You find that the double bond O breaks. The carbonyl compound is reduced here. It is supplying nascent hydrogen and it results in CH3CH3. Whereas in the second case, you get CH3 single bond CH2 single bond CH3. So this ethanol results in ethane. Propanone, on Clemenson's reduction, results in propane. So what is Clemenson's reduction? So Clemenson's reduction it is a method of reducing ethanol or uh, an aldehyde or a ketone, when it is reduced with amalgamated zinc in the presence of concentrated HCl, it results in the formation of alkanes. This process we call it as Clemencians reduction. So this video gives you different methods of preparing alkanes. Hope it is clear. Thank you.